So today we are going to be dealing with, let me move this up a little bit, front of the note packet. We are going to be dealing with equations with variables on both sides. And as it says in the steps, phone away. Thank you. We're going to simplify both sides if there's any distributing or combining of like terms, okay? Distributing meaning there's parentheses. Combining like terms meaning on the same side of the equals, that there's something going on. You won't have step one every single time, okay? But sometimes you will. And then once we've done that, we're going to get all of our variables to one side of the equation by doing opposites and then solve the equation. So we're kind of going to be blending some of the parts that we've been doing before, but we're going to work on doing them all together. I'm just going to peek at one thing really quick here. I got bent over that. Got it. Okay. So here I look. I don't see any parentheses. My like terms are not on the same side of the equals, and that's what I want to stress here. I can't just put the 6x and the 4x together. This equal sign is kind of like having a brick wall there. And for us to get from one side to the other, we got to be sneaky. We got to do an opposite to get there. So step one this time, we don't have it. But my next job is to get my variables all to one side. Now that's up to you how you want to do that. So I notice here that I have x's on both sides. So what I like to do most of the time, which may be different from what you like, I like to get my x's over on the left. So I've got a positive 4x here. I'm going to do the opposite of that positive and do a negative or a minus 4x to get them out of there on one side. And now all of a sudden it looks like the same two-step equations we've been doing. Just one step in. Because I want to get my 2x by itself. How do we undo that minus 7? Hey, yep, and then we get to that last step where, again, we're multiplying by 2. So we're going to divide by 2. Thank you. And we get to our answer. So every time we're not going to have to do a bunch of stuff. Sometimes it's just going to be that one quick step. Now, number 2 is a special case. Ready? Yeah, ready. Here, you're like, I would not suggest moving the 3x to the other side. You're like, okay, why not? Let me do it this way first, and then I'll show you why I don't think it's a good idea. So, since this side only has x, let's move everything to that side as far as our x's go. Use your first example as a practice. Opposite of plus 5x. We're going to minus this over. We're going to cancel those out. Because again, the idea is to get them all on one side of the equals. Ooh. 3 minus 5. Negative 2. And the one thing I've got to be careful about now, because I got my x term alone, is reminding myself this isn't negative. I'm not going to add to both sides. What's the opposite of multiplying by negative 2? Divide. And it is not terrible to punch that into the calculator if you're not sure with the signs or something like that. And look at it that way. Now, let's just say, for instance, you're like, Hardy, I like getting my x's all to the left side, though. Why didn't you do that? Okay, let me give you a quick heads up on why personally I don't do that. What I've seen in the past. So people are like, okay, I want to get this over there. I'm going to do the opposite of this. So I'm going to minus 3x. Okay. Here's where the problem comes in. People all of a sudden think the entire right side of the equation has disappeared. Hardy, there's nothing over there, so I'm just going to solve this. But there is something over here.
Zero.
Zero is.
You can't.
So, well, but we don't need to. We do not need to divide by 0, because if I did my same process, I do the opposite of plus 20, I can still get to the answer. That still can work. But this step right here can cause us a little bit of issue now and then, but I get the same answer. So if you absolutely want to always get x to the left, you can. Just be careful that if everything looks like it gets wiped out on the one side, that there's still a 0 there for you. That's all I would say on that. We get that moved up here so we can kind of have room. You're like, Hardy, I thought you said we got rid of proportions. Well, as a whole, we did. But in this way, not exactly. Every time, like we said yesterday, and I'm going to say it again today, every time you see plus or minus in a proportion with things, x plus 3, x minus 1, put parentheses around them, because then when you go to cross multiply, you're going to remember that before I can do anything else, once I cross multiply, there is going to be distributing. I see parentheses. So on each side, I'm going to multiply that 3 times the x. Then I'm going to do it times the 3. And that's why the parentheses are here, to remind me I've got to do it for both. Multiply it to the x on the right and to the negative 1. Now it looks more like the first two that we've done after we get that step out of the way. So, again, you've got your choices at this point. We can keep moving them to the left. That's fine. So x's, again, opposite sides of the equals. Got to sneak them through the wall. So we'll do the opposite of our positive 4x to get that out of there. Three minus 4 is negative 1. Again, as long as you know the step, it's okay to have the calculator help you if it needs to. Because once I've got all my x's to the same side, now we just start doing the opposites. The opposite of plus 9 is to minus. And again, here, this isn't x minus 1. I'm not going to add it. The negative's in front. It's not in between. So it's the opposite of multiplying by negative 1. And negative times negative is positive. It's just us bringing everything we've done back together as we're looking at these. Now, there's one other thing I want to show you with this. And I want to do a couple of the practice ones with you. But before we get there, over on the back of the notes here, okay, over on to page 2, there's 2 special cases that can come up every once in a while. So you're working through a problem, and you're like, okay, I'm doing all the right things. I look at this, I'm like, all right, Hardy, I got to get all the x's to one side. I'm going to move them over here. I'm going to do my opposite of my positive 2x. And you start going. You're like, all right, so that cancels, that's 6. And you're like, wait a minute. That cancels too. Hardy, there's no variables left. What the heck? So I get here and I'm like, well, let's see. Does 6 equal 6? Well, yeah, that's true. So, if all your variables cancel and it's still a true statement, we say that the answer is all reals, which means I can plug any number in for x and it's going to work. It can be positive, negative, 0, but all my variables went away and I still got a true statement. So occasionally, that may happen. Don't let it freak you out. The other side of that, if I get to the start of my problem, and I'm like, okay, I'm going to undo my 2x here, all right. I get that out of there. So I got my 3. Oh, it canceled out again. But this time, 6 equals 3? No, that is not true. That is false. If all the variables cancel and whatever's left isn't true, that's no solution, because no matter what number I plug in for x, it's not going to work. It doesn't matter what you plug in. Again, it doesn't happen often, but if you run into that situation, keep this handy, because that could be a thing we've got to play with. Now, keep the notes handy. Don't get rid of them yet. The practice that we're working on, Hardy did a terrible thing. I did not put my date on my notes. Hardy. Date. Dates on everything. Okay? So definitely a 922 on there. And one on here as well. And so I start to peek through a bit, and I'm like, okay, what's Hardy all got here? Wait a minute, Hardy. Why you got an inequality arrow in here? What's up with that? Treat it just like you would an equation, okay? If that were equals instead, all we would do, we'd look at our examples and say, okay, it's kind of like this one. I know it's an equals and that's an arrow, but the idea is the same. So we were getting all the x's over to here. So I want to undo this. So I'm going to undo the positive with a minus 6x. (15 minus 6 is 9. And just like we did over here, we're just dividing by the number that's with x that we're multiplying it by. So exact same process. It's just an arrow in the middle. Instead, don't let that freak you out. The rest of them, we've got values to continue to keep looking at. Now, I was trying to see... Ooh, that looks interesting. Let's play. I got 2 others, and then I will get out of the way, and I kind of let you do your thing, and I will float around helping out some. Oh dear, 13. What the heck? Okay. So, first thing I notice, there's variables on both sides. I got distributing. See, that's why I have these here, to help me out some. So we're going to do some distributing. Again, just a really fancy math word for multiply. I don't want to lose my x. Hardy, what do I do with the 1/2 over here if I'm not sure? Okay, I got two options. I think you'd be okay, though. Half of -2 would be -1, because half of 2 is 1. And half of -10 is -5. But again, what if I'm not sure, or a number is, kind of causing me some trouble sometime? Here's what we're going to do. Notice I put the 1/2 in parentheses. If I do that, and then I do that, oh, that's still bright. Hang on a minute. There we go. I can have the calculator help me. That's not a bad thing. Do it with the -10, not the x, just the -10. I got to remember the x part. And get my value, and now again, we're trying to get all our x's to one side. That's a -5x. I do the opposite. Six and 5 is 11. And I'm just slowly, meticulously working on getting that x term alone. The opposite of plussing 21. All about those opposites. And I'm writing too big. I'm going to run out of room. All right. If I'm not sure with my negatives and positives, again, nothing wrong with putting that in there. Make sure your arrow stays. Don't get rid of your arrow. And get to your answer. Last statement from Hardy. Last one. Just a reminder, when you get down to the review, one reminder. Before you try to get rid of the fractions, I know we don't always like them, but before you get rid of it, get it by itself. Here's my one step. I'm going to get you started. Then just think about what you do to get rid of a fraction to both sides. You can knock that last step out. And again, remember, you've got answers at the bottom if you want to check. You have answers up front here in the binder if you want to check. You've got answers online on Classroom. It's good to check and make sure it's going well as you're doing it. But use the examples, use those, and try to get some of